jet-powered aircraft carriers are among the most complex structures ever built by man. It's complicated enough with the warfighting components of launching and retrieving jet aircraft. But beneath the surface is a bustling city with 2 power plants, food services, medical facilities, waste management systems, and even desalination plants that convert seawater to fresh water. The lead ship of the Ford-class aircraft carriers, Gerald R. Ford, is the first new design for an aircraft carrier in the United States Navy since the Nimitz or CVN-68. This is Military Mechanics, and today we will look at the USS Gerald R. Ford. The Gerald R. Ford is the most expensive and largest carrier ever constructed and is scheduled to join the United States Navy fleet in late 2022. The first ship of its class, CVN-78, was commissioned into service on the 22nd of July 2017. She is a supercarrier with a displacement of approximately 100,000 long tons. Her length is 1,106 feet, with a 134-foot waterline beam and 256-foot flight deck beam, and a height of nearly 250 feet. Gerald R. Ford and her sister ships will embark 2 squadrons of 10 to 12 F-35C Joint Strike Fighters, 2 squadrons of 10 to 12 FA-18EF Super Hornets, 5 EA-18G Growler electronic attack jets, 4 E-2D Hawkeye airborne early warning and control aircraft, and 2 C-2 Greyhound carrier onboard delivery planes. It will also carry 8 MH-60S Seahawk helicopters. The carrier will accommodate 4,539 personnel, including ship's company, air wing, and other support staff. The Ford class keeps the basic Nimitz-class hull form, yet has numerous improvements over the earlier carriers. The flight deck of CVN-78 has been completely redesigned and rearranged for 25% increase in the ability to launch and recover aircraft missions. To essentially eliminate horizontal movement within the ship, the Gerald R. Ford was designed with efficient weapon-moving pathways in mind. The modification of the weapons-moving pathways and the placement of the weapons elevators on the flight deck will save manpower while significantly increasing the sortie generation rate. The 2 new design Bechtel A1B reactors generate 600 megawatts of electricity, which is significantly higher than the output of the Nimitz class's A4W reactors. A 600 megawatt output is equivalent to the average electricity consumption of 260,000 detached houses. Ford will require that power not only to reach its estimated top speed of 30 knots, but also to power the new electromagnetic aircraft launch system, which uses electric currents to generate strong magnetic fields that can rapidly accelerate an aircraft to takeoff speeds. The new carrier will also use a new landing system. The new advanced arresting gear uses a water turbine and induction motors to stop the momentum of landing carrier aircraft. In addition, Ford will have the most advanced radar systems in the fleet. The new dual-band radar, which combines the X-band AN/SPY-3 Aegis radar and the S-band volume surveillance radar, will be installed in the Ford. DBR can search, track, and illuminate multiple missiles, detecting enemy aircraft and missiles and guiding evolved Sea Sparrow missiles to intercept them. Ford will have 2 Mark 29 missile launchers with 8 ESSM each, as well as 2 rolling airframe missile launchers for self-defense. In addition, it will have 4 Phalanx close-in weapon systems for point defense against aircraft, missiles, and small ships, as well as 4 M2 .50 caliber machine guns. Because of Ford's large electrical capacity, the ship could eventually mount laser self-defense weapons. Her entry into active service will once again raise the Navy's carrier force to 11 ships. The Navy's carrier fleet is unique in that it has a minimum force level mandated by Congress. USS John F. Kennedy, the second aircraft carrier to bear the name of the 35th President of the United States, is under construction and expected to enter service in 2024.